In simple terms, we break it down. Complex stuff, we make it sound clear and easy for you and me. Billy Goattails and Dave Digital bring knowledge we share. In simple terms, we're everywhere. We love you, fam. Hashtag givers gain. Hashtag givers gain. Hashtag givers
And good morning, goats, and welcome to the Simple Terms podcast. I am your host, Dave Digital, and I am going to be taking you through this journey today. Sorry about that. We got off to technical difficulties going on there. Let me put it back over there. Hey, good morning, everybody. If you can hear me and everything is good, put a one in the chat. One in the chat if you guys can hear me. I hope everything is working okay. Looks like Jesse maybe didn't get to hear the intro, but that's okay. Sometimes we have glitches going on. But good morning, everybody. This is the Simple Terms podcast where we break down complex topics in simple terms. We are right here on the Billy Goattails Network, where our ethos is based on Givers Gain. It's good to see everybody here this morning. I hope that each one of you guys had a Merry Christmas. I hope that you are getting ready for your new year. I hope you have big plans. I hope this year holds everything that you want, that you desire. I hope that last year you learned everything that you wanted to learn, or so many things that you wanted to learn. You have so many good lessons from last year. I hope that last year you got everything that you wanted out of it, and everything that you didn't get out of last year, I hope that you have a plan for this year, going into 2026, that you are going to make changes and get everything that you want out of the new year. So I'm excited about the new year. Really cool things going on. I did a thing last night. We won't really go into too much detail. I do want to share with you guys my chart on the Bitcoin. So let's take a look. Man, this thing has not been doing any moving. Let's see here. There's the Bitcoin chart. So if you can see, I'm on the 1 hour. And this is what we've been doing on the 1 hour. I think that it's going to come take these lows right there. I mean, if you look here, and I'm not a pattern guy, but I mean, we've barely tapped this golden pocket 786. We haven't filled that value area low again. And then you have this thing. Like I say, I'm not a pattern guy, but that looks like a left shoulder, a head, and a lower right shoulder. So what I would like to see, I would like to see us come up, take these highs, give us some sort of a bear div or a SFP, and then come take these lows. So I've got an alert there. If we come up and take those highs, sweep the highs, and then I see a reaction, if I have a chance to look at it while we're live, if it happens while we're live, then I'll take the short. If not, if it just comes down before it takes those highs, well, that's just is what it is. So I just would like it to take those highs first, and then that would make it easier for me to set my stop loss wherever it needs to be. So today, what we're going to be discussing is the how to stop AI hallucinations. So I'm not even sure if you guys understand what we mean by AI hallucinations. I'm sure some of you do, but maybe a couple of you don't. So AI hallucinations is whenever the AI will confidently give you an answer and even give you sources that is completely wrong. So this happens a lot whenever you are building a project that maybe takes a little bit longer, or the AI gets a little bit deeper into the conversation. Then it may hallucinate if it just does not know the answer, and it'll hallucinate very confidently, um, and that could cause problems, especially if you're in a larger workflow. So let me just say hi to all you guys real quick. I know I saw Jesse in there. Wow, Alexandra G just spreading the love across all the channels this week. So amazing, Alexandra G. Good to see you this morning. I hope your move was good. All set analyst used to be all set miner and was also just all set. So we got all set the analyst now. All set analyst. Good to see you this morning. Like I said, he's gonna have to be running. Just came in for the light. I really appreciate that, bub. Poman 13, good to see you, Poman. Hopefully that we get to see you this year at the Billy Hotel or weekend at Billy's. That would be really cool to see you this year. Local for crypto. Good morning, L4C. Steve Hickey, good morning to you. Good morning. Good morning. Good morning. We have Nightbot is already active. Crypto Billy. Good morning, Crypto Billy. That, as you guys know, is the founder of Billy Hotels and a friend of many of us in this space, many of us, and it goes way beyond just hanging out in chat. So you guys know, if you know, you know, but Crypto Billy is really, really, really there for a lot of folks behind the scenes, and we appreciate him. Let's see, Curtis Hill. Good morning, Curtis. Good morning. Good morning. Good morning. Harp. Good morning to you. Let's see, Keith. Good morning, Keith. Crypto Coin Mindset. I did not get over to Crypto on the Rocks last night or even last week. I don't think I've missed you guys for a couple of weeks. I hope to get back over there. I think the last show I was on, I mean, I think I must have ruined the show because I came on screen on camera, and then shortly after that, we were having discussion, and then DC Port Corp kicked everybody off and shut down the stream. So I don't think he wanted us on there. Sorry for ruining that stream for you, Keith, but maybe we can do it again sometime. Let's see, who else am I missing? Mortimer Duke, good morning, good morning, good morning. I think that's everybody. If I missed you, hey, say hi in the chat. I'll be keeping my eye on it. You guys know how it works. Say hi in the chat if I missed you, and I will say hi back to you. So what I'm going to do now is I'm going to load up our program for today. What we're doing is AI hallucinations. So they call it RAG, but we'll learn more about that as we get going. This is going to be the deep dive. We're going to do an interactive deep dive today. Let me go ahead and share my screen. Bam. All righty, guys. So we're going to get started. Let me know if everybody can hear it. So once I get going, put a 1 in the chat. And if you can hear it, everything is good. We will move forward. If you have questions, ask your questions. I will star those questions, and then I will come back to them whenever we see an opportunity to hop in and not get the AI off track. So let's get started. Wait, before we get started, I forgot, I got to do things. So let's get started.
Welcome to the Deep Dive, the show where we take this fire hose of information
in the
you've
chat
given us, all the academic
if you can hear
surveys,
the AI.
architectural guides, the technical specs, and we distill it all down.
We really do. And today we are wrestling with what is, arguably the single biggest headache in the world of generative AI.
Okay, let's hear it.
The problem of confidence without facts. We're talking about hallucination. That moment your seemingly helpful AI assistant just completely veers off the rails and delivers plausible yet total fiction.
And we've all seen this. I think everyone listening has had this experience. You ask a large language model, an LLM, a question, and it comes back with this absolute authority. It generates content that sounds perfectly researched, it's well articulated, but it's just fundamentally demonstrably wrong. It's a real crisis of trust.
It is. It's the digital equivalent of
But
a
it's just
really
fundamentally
well-dressed politician standing up and stating with zero hesitation, yes, it is a known historical fact that Thomas Edison invented the first practical telephone.
Right. It's said with such confidence, I almost believe it for a second.
You do. It's delivered with this perfect professional cadence. But you and I know the reality is Alexander Graham Bell invented the telephone. Edison, he's famous for improving the light bulb, building on other people's designs.
And that's what the researchers call a factual contradiction.
Exactly. And sometimes it gets even weirder.
Worse than just getting a fact wrong.
Oh, yeah. Sometimes it just makes them up out of whole cloth. The research papers you shared have this great example of factual fabrication.
Okay.
Like an LLM claiming with that same confidence that the construction of the Eiffel Tower in 1889 led to the extinction of the non-existent Parisian tiger.
The Parisian tiger, which never existed.
Never existed. It creates this beautiful, compelling story, but the core fact is just that poof. It's a complete fabrication. The model is guessing.
And that guessing, that reliance on its own internal, maybe stale or just plain wrong training data, that is exactly what we are here to stop today.
That is the mission for this deep dive. We are introducing the concept of retrieval-augmented generation.
Or RAG, as we'll be calling it.
RAG.
So the mission is pretty simple then. We want to contrast that closed book LLM, the one that's just relying on its static, memorized knowledge, with a new evidence-based system.
We're taking the AI from a confident wrong answer machine.
To one that has to show its work, show the receipts.
Exactly. Show the receipt. So our goal today is to explain RAG in really simple terms, walk you through the core architecture step by step.
Then we're going to do a kind of conceptual stress test with some really tough real-world questions.
And then we'll look at the engineering required to build these things so they're actually reliable and secure in a production environment.
So it's not just about what RAG is. It's about how it fundamentally changes the whole relationship between the LLM and, verifiable truth.
That's the goal.
Okay, so let's start with the definitions. The source
Oh, wait. Someone wants to join. Hey, go for it.
Good morning. I'm Dave Digital, and you guys are live on the Simple Terms podcast. This morning is Saturday morning, December 27th. We are 2 days after Christmas here in America, and I want to welcome you guys, and I want to thank you for where you are right before you get started. I don't want you to lose your place, but I do want you to say hi to some people that we have live in the chat. We have Alexander G, who sent 2 super stickers this morning. We want to say thank you to her. We have Jesse Halluck. We have All Set Analyst. We also have Keith from Crypto Coin Mindset. We have Proman13. We have Loco for Crypto. We have Steve Hickey. We have Crypto Billy, the founder of Billy Go Tales. We also have Harp. Let me see. We also have.
Good morning, David.
Welcome, Dave.
Thank you so much for the introduction and for letting us borrow your airwaves this morning.
It's Saturday, December 27th, and we are live.
And we are really delighted to be here with the Simple Terms podcast audience.
We see Alexander's TV and all our friends.
Hello to the analysts, to Poland13, Steve Hickey, and Crypto Billy.
We appreciate all of you for tuning in for this deep dive into AI truthfulness.
The timing is actually perfect because we just finished setting the stage on LLM hallucination.
Yeah, that problem of the Parisian tiger that never existed.
Exactly. And the whole point of this segment is to introduce the solution, which is RAG.
RAG, or Retrieval-Augmented Generation.
Before we jump into the architecture, let's just make sure we are all on the same page with the core definitions.
Okay, let's unpack this. The sources we looked at propose a really useful taxonomy.
They split LLM hallucinations into 2 main categories.
And while that factuality hallucination, like the Edison or the Parisian tiger examples, that's the one that grabs the headlines.
Lebrick is actually primarily focused on solving a different category, which is faithfulness hallucination.
Okay, faithfulness. Tell us more about that.
Faithfulness is about the generated content diverging from the context you provided to it.
This is the critical part for RAG.
Exactly. If the generated text diverges from the specific evidence you literally just fed the model, that's context inconsistency.
So the smoking gun is right there in the prompt.
It is. Remember that fact-checking example we discussed earlier, Dave?
The Eiffel Tower example, the Parisian tiger.
Yes, that was a factual fabrication, but RAG primarily prevents context inconsistency.
So RAG is specifically engineered to force the LLM to stay faithful to the context we give it.
Precisely. RAG shifts the entire source of truth.
Okay, so let's nail this down. RAG in one line.
RAG, or Retrieval-Augmented Generation, is an AI framework that optimizes an LLM's output by dynamically retrieving relevant, up-to-date information from an external knowledge base before it generates a response.
And we keep coming back to this analogy of the closed book versus the open book exam.
It's the best way to think about it.
A standard standalone LLM is taking a closed book test.
It relies only on the static, memorized knowledge it got during its initial training.
So if a new company policy was announced yesterday, the closed book model has no way of knowing about it.
None. RAG, on the other hand, is the ultimate open book exam.
The system first goes and browses an external knowledge base, which can be updated instantly with that new policy or today's sales figures.
It finds the relevant facts, and only then is the LLM allowed to synthesize an answer.
And this is a really profound shift in the model's cognitive task.
It changes the core requirement from pure, often unreliable recall.
From just digging up facts from its own memory.
Right, to a task of comprehension and synthesis based on verifiable evidence that's presented right there in the prompt.
We're not retraining the model, we're giving it a superpowered research assistant before every single question.
That makes so much sense.
By shifting the requirement from remembering to reasoning, you just dramatically boost accuracy and trustworthiness.
Absolutely.
Okay, let's move on from the what and get into the how. Hey, yeah, what's up?
Yeah, before we move on to the what and get into the how, we had a few more people join us. I would like for you to say hi to them. We have maybe a Band-Aid. We have Chris Klein. We have Steve Hickey and Curtis Hill that have joined us in the chat. And then I want you to slow down before you go into the second part and go back and give us some real world examples of how we would implement that first section in our actual use case in an actual prompt.
Dave, thank you for being the best community manager.
Good morning, and welcome to the whole crew.
Hello to maybe a Band-Aid and Chris Klein.
We are so happy you joined us this morning.
And we absolutely appreciate that feedback about pacing.
We can definitely slow down and give you some real-world examples.
You want to see how we limit hallucination in actual RAB use.
That's the heart of the matter.
The primary way we limit hallucination, that factual fabrication,
Is by giving the model a safe way out.
the LLM's default is to always answer a question.
So we explicitly instruct it in the system prompt.
We tell it if you can't find the answer in the provided documents.
You must respond with, I do not have sufficient information in the provided sources.
This is non-negotiable in production RAG systems.
It forces the model to choose humility over fabrication.
Another powerful technique is grounding and citing.
We make the model show its work for every claim.
The prompt demands, quote the line, then explain in plain English.
This makes the output verifiable, which prevents ungrounded guessing.
Think of the Parisian tiger. Without RAG, the LLM fabricates.
With RAG and those strict grounding instructions,
You have to either find a document about the tiger or say, I don't know.
that I don't know is the single most important safety feature.
We will come back to this safe way out in round 3 of our stress test.
That's where we cover the out-of-scope query,
But for now, let's keep that grounding principle in mind.
and we can move on to the how, section 2.
Reconstructing the RAD architecture,
We said it's a two-phase workflow.
combining an offline prep step with a real-time query step.
This two-phase process is what makes it scalable and efficient.
We do the computationally expensive heavy lifting of data prep once, offline,
So that the real-time part, the actual answering of the question, can happen instantly.
on demand. Exactly.
So let's start with phase 1, retrieval, and specifically the offline process.
This is often called data ingestion. What does that prep look like?
The offline process is all about preparing, organizing, and indexing your raw knowledge base.
It's a 3-step flow, sources to chunk to index.
Okay, step 1, sources.
Step 1 is gathering your raw materials,
Your policy manuals, legal documents, technical specs.
whatever source material you want the AI to learn from.
And this is where the first real technical challenge comes in, right?
You can't just feed a 100-page PDF to the LLM every time.
No, you'd overwhelm the LLM's finite context window.
It would be insanely expensive and way too slow.
So that's why the first indispensable step is chunking
Exactly. Large documents have to be logically segmented.
into smaller, manageable pieces or chunks,
We need these chunks small enough to fit in the prompt and be retrieved precisely.
but also big enough to retain their semantic meaning.
Once we have these nice bite-sized pieces of text,
How do we make them searchable by meaning, not just by keywords?
that brings us to step 2, chunk to index.
And this is where the magic of vectorization happens.
We use a specialized type of model called an embedding model.
Like OpenAI's text embedding 3 small or other open source ones.
Right, like BA Edge Base NV 1.5.
These models take those raw text chunks and transform them.
Into dense, high-dimensional numerical vector representations.
So if the original text trunk was a paragraph about,
Say, the flexibility of the new hybrid work policy
the embedding model maps the meaning of that paragraph to a specific set of coordinates.
in a high-dimensional space.
Precisely. And these numerical vectors, these embeddings, are then stored,
In a specialized information retrieval system.
specifically a vector database like Pinecone or Weaviate,
And this database organizes the data based on semantic closeness.
ready for lightning-fast relevance searching.
This whole offline process creates our vectorized, ready-to-use knowledge index.
That distinction is so important. Why can't we just use a normal keyword search for this?
Because traditional databases rely on exact keyword matching.
If I search for a remote work policy,
But the document only uses the phrase telecommuting guidelines.
a traditional system would probably miss it entirely. It finds nothing.
A vector database, though, measures the semantic distance between my query vector and the document vector.
If they are conceptually similar, their vectors are close together.
And the system retrieves the document instantly.
Even with zero keyword overlap, that really drives home the power of semantic search.
Okay, let's switch gears to the online process.
What happens in real time the moment I type in a query?
The moment you submit your... Yep, go on.
Okay, before we go on to the next area there, that was kind of confusing for me. So I'm not sure that I understand all of it. You said words like text chunks and models and vectors and vector databases and vectorized or ready to use. And I don't really understand how all that goes together and how does that help me whenever I'm prompting AI say to write a title and description for a YouTube video that we've discussed.
That is a fantastic question.
And it is the core of the whole thing.
You're right. We just threw a bunch of terms at you.
Text embedding vector database.
Let's put those Legos together right now.
Okay, let's unpack this with a real-time example.
Imagine you type in your question, what is the new flexible work policy?
That's your natural language query.
The first Lego is the embedding model.
It takes your question and turns it into a mathematical vector.
That vector is the numerical meaning of your question.
The second Lego is the vector database.
That's where we stored all those chunk vectors earlier.
The ones that represent your company documents.
Your questions vector goes to the database.
And the database instantly finds the closest document vectors.
Like finding the nearest neighbors in that high-dimensional space.
If the chunk about telecommuting guidelines is semantically close to your flexible work policy query,
that chunk is retrieved.
that retrieved chunk is the final Lego,
We take that text chunk, which is the evidence,
and we combine it with your original question.
we stuff them together into the final prompt for the LLM.
That's how the LLM gets its context.
It sees your question and the relevant evidence together.
The LLM doesn't search, it just reads and answers.
So RAG is the entire pipeline.
It's the mechanism that takes your question, gets the evidence, and gives the evidence to the model.
That's the online process the moment you type your question.
Your question, the orchestration layer kicks in.
This is the central coordinator for the whole system.
And what's the first thing that orchestrator does?
It takes your natural language question and converts that query into an embedding vector.
Using the exact same embedding model we used during ingestion.
And that consistency is non-negotiable for the system to work.
Absolutely non-negotiable. If you use a different model, the semantic spaces just won't line up.
Your search will fail spectacularly.
Okay, so that query vector is now sent off to the vector database.
This is step 3, query to retrieve the top K results.
And the vector database performs that similarity search.
It measures the numerical distance between your query's vector and all the stored document chunk vectors.
It then retrieves the top K most similar chunks.
That K could be the top 5 or top 10 most relevant segments of text.
Right, depending on how much context you want to provide to the model.
And here's the critical moment. We've retrieved the evidence.
Now we finally move into phase 2, generation, where the LLM comes into play.
But its role is now dramatically limited. Phase 2 is all about the final answer synthesis.
The system takes those retrieved top K chunks and combines them with your original question.
This is the prompt augmentation step. Some people call it prompt stuffing.
So the final prompt is this massive, highly structured package.
It's basically telling the model, here's the user's question.
And below, here's the exact context you need to answer it.
Exactly. And that augmented prompt is sent to the generative LLM.
And crucially, the system prompt has explicit, non-negotiable instructions.
Telling the model to synthesize the final answer exclusively from the provided context,
Not from its own internal knowledge.
not from its internal parametric knowledge.
And because that context is right there, the model synthesizes the response,
And now it can and should include citations.
showing exactly which chunk or which source the information came from.
And that transforms an unsubstantiated guess into a verifiable, auditable statement.
This is some architectural blueprint.
Oh, yeah. Go on.
Okay, so Keith from Crypto Coin Mindset, he and I seem to be on the same page here. He said, maybe I'm just tired, but this is frying my brain. So what he's saying is all of these terms are hard for us to understand for a normal use case. So can you give us an example of what happened with a prompt and an example of that prompt before RAG, and then an example of an optimized prompt after RAG for a simple use case, like developing a YouTube video or something like that?
You are absolutely on the right page.
You are catching the critical points.
And honestly, the terms we use can be brain frying.
That's why we're here to break down the friction points.
You want a simple example of a normal use case.
And then an example of a problem that RAG solved.
Let's anchor this with a very clear, everyday corporate use case.
We will use the company policy manual analogy again.
Before RAG, let's say a customer support agent asks the old LLM.
What is our company's warranty coverage for the Model Z?
The old LLM, relying on its internal memory from training 2 years ago, might confidently say,
The warranty is 90 days, no exceptions.
but the company updated the policy last month to 180 days.
The old LLM has failed the factual contradiction test.
It's a hallucination because the knowledge is stale.
Now let's use the RAG-enabled system.
The RAG system has the new, updated 180-day policy in its vector database.
When the agent asks the same question, the orchestrator works.
It converts the query into a vector.
It searches the vector database and retrieves the chunk that says,
Model Z warranty is 180 days effective October 1st.
The LLM gets that text context in the prompt.
And because it's forced to use the evidence, it outputs the correct answer.
And it adds the citation, proving it's grounded in the new document.
Oh yeah, let's hear it.
Okay, so what you're saying is RAG is basically an update that these LLM models have that we don't necessarily have to introduce to it. This is already there, making the models better in most cases. Am I understanding that?
That is a brilliant way to phrase it.
You are capturing the core difference.
Here is the key distinction, though.
RAG is not an internal update to the LLM itself.
That LLM is still the same closed book model.
The GPT-3 or the BERT architecture is static.
RAG is a new external system we introduce.
It's an architecture built around the LLM.
It's the research assistant, not the student.
Remember the cost discussion.
We specifically use RAG because it's up to 20 times cheaper.
It's cheaper than retraining or fine-tuning that entire LLM model.
Fine-tuning is what bakes the knowledge directly into the LLM's weights.
That's the internal update you mentioned.
RAG avoids that expensive, continuous fine-tuning cycle.
Instead, we just continuously update the external vector database.
So RAG is the external mechanism we introduce.
It dynamically feeds the LLM with fresh, verifiable context.
That's how it makes the models better in most cases.
It provides the grounding.
In the new
Oh, go for it.
And the RAG comes from the user, like me, inside of the prompt?
That's a great clarifying question.
All right, you are hitting the nail right on the head.
RAG, the Retrieval-Augmented Generation, doesn't come directly from you, the user.
It comes from the external knowledge source, the database we set up.
Think of it this way. Your input query starts the RAG process.
You ask the question, which is what we call the user input.
But the RAG itself is the mechanism that goes and grabs the evidence.
It's the retrieval system that retrieves the most relevant document chunks.
And then those chunks are what get stuck into the prompt.
So RAG is the external data flowing into the prompt, augmenting it.
That's what allows the LLM to provide the verifiable answer.
That distinction is so critical to understand
It provides the grounding.
in the new document.
Oh, yeah,
I'm so worried with all of my questions that you guys are going to get off track and you're not going to remember where you were and you won't continue correctly. But I hope that you do. I think that you're getting better, and I don't think you're going to have any glitches. But so, okay, so this is RAG not for a home user of AI. This is for the enterprise or the office user of AI. And then the office user doesn't actually do the RAG. It's built into the LLM system at the office from the company. Is that right? Or am I just totally off base and lost here?
That is a wonderful, complex question.
And first, thank you for sticking with us.
You are never getting us off track. We love your questions.
Your questions are what make this whole conversation possible.
And you are completely correct on 2 points.
Okay, let's unpack this.
Point 1, RAG is absolutely primarily an enterprise or office tool.
While a home user might encounter RAG in a specialized application.
The primary value is for businesses that have proprietary, constantly changing knowledge.
Like internal documents or policy manual.
It's not built for general web searches. It's for specific knowledge bases.
Point 2, your question about the office user not writing back to the LLM is absolutely correct.
The office user or the agent only interacts with the final application interface.
The office user inputs the question, the prompt.
But the RAG orchestration layer handles all the complex steps we described.
It does the vector search, it stucks the context into the prompt.
It manages the flow. The user never sees the complex prompt structure.
They just see the final grounded answer.
So that's what we're focusing on the enterprise use case here.
Because that's where RAB solves the most critical problems of factuality and security.
Now back to our stress test example.
The one RAG, oh yeah, let's hear it.
Okay, so RAG does that. I don't think that was our main focus today. I think what I was hoping to get out of you guys was how we could stop the hallucination more on a personal use case. Whenever, let's say, as a creator on YouTube, like Keith from Crypto Coin Mindset, or Joe from Trade Intuition, or myself here on the Billy Goat Tales team, uses AI, and let's say we're doing research, and then it confidently gives us the wrong answer about a topic that we're researching. I think that's more what we're trying to stop here. You have that. I mean, that knowledge should be there in your knowledge in the sources database, correct?
That is a phenomenal pivot.
And you are right, we absolutely should address the individual creator.
Because hallucination isn't just an enterprise problem.
It's a huge problem for content creators like Keith and Joe.
When you use an LLM for quick research on a top story,
And it gives you a confidently wrong answer.
That damages your personal credibility.
It absolutely does. And you're asking a great question. How do we stop hallucination there?
For a personal user, you typically don't build your own RAG pipeline.
That would be way too much setup and complexity.
But the concept of RAG is what you rely on.
Most mainstream AI tools, like those you use for research now, are quietly using RAG.
They connect to live web search or internal verified knowledge bases.
So when you ask about a top story
The LLM should ideally be retrieving that up-to-date article from a search engine.
and using it as context before generating the answer.
Your expectation that the correct story should be in the source database is correct.
But the crucial point is that RAG is what forces the LLM to use it,
Without RAG, the LLM might default to its stale internal memory.
even if the correct information is available online.
So RAG is the external mechanism that brings the fresh fact into the conversation.
It's the difference between a creator guessing and a creator citing a source.
That's why we stress the importance of the citation feature.
If the AI tool doesn't show you the source, you can't trust it.
For a creator, the rule is simple. If the answer isn't grounded, you must verify it manually.
RAG just gives you the mechanism to check the receipt.
Now, let's bring it back to the stress.
Best example we were starting.
The one RAG is supposed to fix.
Oh, yeah, uh-huh.
Yeah, so you were talking about outdated models. So I think a good example of this is Army Piper, creator of the Piper Network, was live on screen one time, and he was talking with, or he had some footage of him talking with his AI, which was a voice model of ChatGPT 4, and it kept insisting that the president was not President Trump, and it was either Kamala Harris or Gavin Newsom or something like that. So that model, the ChatGPT, whatever model that was, 4.1 on the voice model, was not using RAG. And that's an example of how it can hallucinate. Is that correct?
That is a phenomenal real-world example.
Thank you for sharing that context.
You are absolutely nailing the problem of outdated models.
That is precisely what we mean by a knowledge cutoff.
That LLM was trained on data up to a certain date.
Let's call that the knowledge cutoff date.
If the LLM's memory cutoff was before that election,
Or before the German president took office.
it has no parametric knowledge, no internal fact about the new leader.
That's because the LLM's internal knowledge cannot be updated in real time.
The LLM is essentially forced to hallucinate the previous answer.
Or generate an answer based on its stale internal data.
This is a classic case of what the research calls factual fabrication.
It's an error because the model is prioritizing fluency over truth.
And that's exactly where RAG shines for creators.
RAG steps in and provides that up-to-date context.
If that AI system had been RAG enabled,
It would have dynamically retrieved a current news article,
an article confirming the result of the election.
and that fresh external fact would override the stale internal memory.
So RAG is the bridge over the knowledge cutoff gap.
It's the mechanism that ensures the facts are current.
One RAG is supposed to fix, but sometimes fails.
We call that the retrieval failure.
Let's use the enterprise example. Is the Model Z good for beginners?
Oh, back to our listener.
Before we get into that enterprise example, I just want to say hi to a couple more people that have joined the chat. We have Wick589 has joined the chat. We also have Joe from Trade Intuition, who I think yesterday walked for over 4 miles on the treadmill. And then we also have Reliable J in the chat. Now, Wick also had a comment. Wick said, better yet, how can we leverage hallucination and mine them for value? So he wants to leverage the hallucinations, and he wants to mine them like we mine Bitcoin for value. He put a little smiling emoji, but go ahead and say hi to those people, respond, and then continue where you are.
That is fantastic.
Welcome, Quick589,
And hello to Reliable J and Joe.
who is already putting in the miles.
We love the community engagement.
And thank you for reading out that question from Reliable J.
The question is key. How can we leverage this relationship?
If RAG is the external mechanism,
And the LLM is the synthesis engine.
the relationship we leverage is the trust established by the RAG system.
It's the grounding and the citations.
We leverage the fact that the LLM is forced to be faithful.
Faithfulness measures if the answer is strictly supported by the context.
If the LLM generates a claim, that claim must be verifiable in the retrieved chunks.
This relationship means we can trust the answer.
Because we know the model used the external up-to-date data.
We are essentially leveraging RAG to turn an ungrounded guess into an auditable statement.
We can't stress that auditability enough.
That's the core leverage point for both enterprise and creators.
It's the proof of work.
Okay, let's circle back to our stress test.
We were just about to.
Oh, yeah.
Yep, right before we circle back to our stress test, I want you to say hi to one more viewer that we have in the chat. It's our first comment that I've seen today from X. We do have several viewers over there on X. It's Alex. Collingborn, I think is how I'm seeing that. Alex Collingborn, good morning to you. I would like for you to say good morning to them and then move right on where you left off.
We would be delighted to welcome Alex to the chat.
Hello, Alex. We are so glad you joined us this morning.
Thank you so much for reading out the names, David.
We appreciate all the questions and insights coming in.
And we are happy to see you here on X.
You want to talk more about RAG and how it helps creators?
That is exactly where we were,
We were about to dive into our conceptual stress test
which directly addresses the challenge of making AI reliable.
for creators like those in your chat.
So we'll continue with the stress test,
But we'll keep relating it back to the personal use case.
especially how the limitations of RAG affect you.
We were just about to dive into retrieval failure.
The one RAG is supposed to fix, but sometimes struggles with.
Let's stick with an ambiguous example query.
Is the Model Z good for beginners?
That is still a messy, subjective question for the enterprise.
Or for a creator asking, is this new crypto concept safe?
The RAG system retrieves technical specs or white papers,
But nothing about subjective user experience or risk assessment.
so it gets irrelevant chunks, not the subjective answer we need.
Consequently, the LLM is forced to say, I do not have sufficient information in the provided sources.
That is RAG working by forcing the model to be humble.
It has to stay grounded in the documents we prepared.
We avoid the hallucination, but we highlight the limit of the knowledge base.
We call that the out-of-scope query.
But for now, just remember that RAG is the architecture that enforces evidence.
It ties the LLM's output directly to your current verified sources.
And that evidence is dependent on how well we prepared the data.
We said no fancy retrieval can save a poorly constructed knowledge base,
And at the heart of that is the art of chunking.
which is, I think, the most underrated but most crucial factor.
It's a real Goldilocks problem for the system.
How so?
The chunk has to be small enough for
Yeah.
Yeah, before you tell us how it's a real Goldilocks problem for the system, I want to recognize that we have a new viewer in the chat. It's Brandon, and Brandon says 6-7. So I want to reply to him 6-7. And then Crypto Billy had an interesting comment about the use of AI in this Simple Terms podcast. He says, this show isn't even live. I watched this whole show yesterday. DD is showing you how his avatar can host a show that was pre-recorded and remain interactive with the chat. Amazing. So obviously he's kidding because I am live, or am I? We don't know. You guys go ahead and respond to that, and then go ahead and continue right where you left off.
We hear you, Dave. Thank you for that kind of feedback.
That really means a lot to us, honestly.
The fact that you watched our preview show, The Loud House, is amazing.
We specifically make these podcasts interactive.
Because your questions, your timing, it drives the conversation.
We love that you chime in and keep us on track.
And we are definitely going to dive into RAG's complexity,
But you mentioned the service of AI,
which is really about the reliability and consistency.
and that consistency starts right here with chunking.
The quality of the RAG service depends on this foundation.
So let's keep that in mind as we discuss this Goldilocks problem.
The chunk has to be small enough for precise retrieval.
So we don't grab huge, irrelevant blocks of text.
But it also has to be large enough to retain its full semantic meaning.
We just talked about that concept of semantic coherence.
What happens if the chunk is too small, let's say 50 characters?
If it's too small, you lose all the surrounding context.
It's like finding one puzzle piece, but missing the entire picture.
That's a great analogy. And if the chunk is too large,
You introduce noise into the prompt.
exactly. If you retrieve a 5,000 word chunk for a 5-word question,
You're wasting the LLM's finite context window on irrelevant fluff.
which we now can degrade performance and lead to errors.
Okay, let's break down the common strategies for this process.
The starting point for everyone is fixed size chunking.
This is where you chop up the text based on a uniform size, maybe 500 characters.
It's fast, it's simple, it makes batch processing a breeze.
But the huge drawback is that it completely ignores semantic boundaries,
So it could just slice a sentence right in half, breaking the thought.
or slice right through the middle of an important technical table.
So to mitigate that, a really crucial technique is to implement overlap.
How does overlap work in practice?
You typically use a small overlap, maybe 10 to 20% of the chunk size.
You repeat the last section of chunk A at the beginning of chunk B.
This preserves the contextual continuity across those artificial boundaries.
So if a key idea was split by the cut, the overlap ensures it is fully captured.
Which makes it retrievable.
Without overlap, fixed size chunking is almost always a guaranteed point of failure,
Okay, moving up in sophistication, we have content-aware chunking.
which actually respects the document's inherent formatting.
Yes, this leverages what the document structure is already telling us.
Sentence-based chunking is excellent for structured data like FAQs,
where each sentence is a complete, self-contained thought.
and for longer form content like reports.
For narrative reports or articles, paragraph-based chunking is often better.
Since a paragraph usually encapsulates a single topic or argument.
But the downside there is that paragraphs are all different sizes. Exactly. And that's why many production systems just default to recursive chunking.
This is super robust because it tries a prioritized list of separators.
How does that work?
It might start with the biggest separator, like a double new line for paragraphs,
If the resulting piece is still too large, it recursively breaks it down
using smaller separators than sentences, than words.
until it meets the desired size limit.
So it intelligently tries to keep related text together.
Oh, go for it.
Look, Keith and I are really trying to follow along, and now probably Billy's even lost. I mean, how does this have to do with us? You're talking about these chunks and these separators. I mean, normally as a creator, as a normal user, we just type in our prompt into the AI, and then we type in, or then we maybe put in a couple files. All this isn't kind of making sense in our real world use case. Can you kind of break that down for us?
That is a completely fair point.
And we understand why you feel lost here.
You're right. As a creator or normal user,
You just open the app and type your prompt.
you don't have to worry about chunking or records.
You just want the AI to do its job.
Here's the key. The reason we are deep diving into chunking and vectors.
It's because they are the secret sauce that makes the AI work for you.
The RAG architecture is what happens behind the prompt window.
When you type your question and maybe upload a file,
The system takes your file and right away chunks it.
it then converts those chunks into vectors, those decorators you mentioned.
And that all happens before the LLM ever sees your question.
So while you don't do the chunking determines the quality of your AI's response.
Add chunking means the AI can't find the fact you need.
And it falls back to the fast guess we warned about.
We talk about it so you know what reliable AI service actually requires.
It needs that robust foundation.
Let's pick up right where we left off on chunking sophistication.
That process maximizes the chance of semantic coherence without massive overhead.
It's the smart default for complex documents,
We were just about to describe the most advanced technique.
the one that is the most accurate, semantic chunking.
How does semantic chunking go beyond just structure?
Semantic chunking actually uses the embedding model during ingestion,
It goes through the document sentence by sentence.
generating an embedding vector for each one.
Then it calculates the distance between the vectors of consecutive sentences.
And if the distance is large,
That indicates a significant semantic shift. The topic has changed completely.
so it ignores physical breaks and only cuts when the actual meaning changes.
That sounds incredibly effective for accuracy. What's the catch?
The catch is cost and latency during ingestion,
You have to make an embedding model call for every single sentence.
which could be millions of calls for a large dataset.
So while it results in highly coherent chunks that boost retrieval accuracy later,
It's significantly more expensive upfront.
it's a classic engineering trade-off. Accuracy payoff versus processing cost.
Okay, so once we have these perfect chunks, we need to retrieve the right ones.
And that means acknowledging that pure semantic search isn't always enough.
And this brings us to advanced retrieval, where hybrid search is the new best practice.
Search is fundamentally split into two types, semantic and lexical.
We've covered semantic search. It uses dense vectors to find concepts, meaning, intent.
It's great for paraphrasing and synonyms.
But what if you're looking up a specific technical acronym like TDP 43?
Or a precise internal document ID, HR form/902B.
Semantic search might struggle there because the code lacks conceptual meaning.
Exactly, and that's where lexical search comes in.
It's the traditional keyword-based approach, often using sparse vectors like BM25.
It is highly precise when you need to find exact keywords and identifiers.
And the real world demands both conceptual understanding and precision.
So you combine their scores into a single final ranking.
And this is where the critical tuning knob comes in, the alpha parameter.
Think of alpha as a tuning dial on a radio.
Okay, I like that. How does the dial work?
The alpha parameter is a weighting factor.
It balances the dense semantic score and the sparse lexical score.
The formula is a linear combination of those two scores.
So if I turn the dial all the way up to 1.0,
I'm basically telling the system, I only care about the semantic score.
correct. That's generally better for conceptual queries.
If you turn the dial close to 0, you're prioritizing the lexical keyword score.
You're saying, I need this exact acronym.
Exactly. That sounds like a
Are we still live? One in the chat if we are still live on the YouTubes here. Let's see if I can get them to catch up right where they left off. Looks like everything. Yes, we're back. We're back. So we'll see. I think there, guys, we're getting really close anyway to the end there. So we'll go back into it to see if they can remember where they were. No, they don't remember. I think we'll just stop that one on that note. It looks like we had a little malfunction there at the end. But basically we were getting into really the nuts and bolts uh, on how these prompts and these AIs and this LLM is working in the background. So it's a lot of stuff to dive into. I think this was a little higher level than what we were looking for. I think we were looking for more user level. So we may revisit this topic one more time in the near future. And to get, because it's just constantly evolving. I know you guys are using AI. I'm using AI heavily. No matter if it's with our trading in Bitcoin or if it's with creating or if it's just whenever we want to cook some dinner or if we want to look at our health plan or not our personal health plan, if we want to, look at our diet, all these things that we're using AI for. And we definitely don't want it to um, hallucinate on us and give us some wrong information. Some people are even, AJ from the Y-Files even uses AI, seems successfully for his health problems. He was just talking about, he developed some sort of what he thought was allergies with runny nose. He's going through 3 boxes of tissue every day. His doctors can't figure out what's going on. He thought it was just because he moved to Plano. So the whole time he was in Plano, he was dealing with it. Then the whole time he moved out of Plano and he went to Las Vegas, he was still dealing with it. The doctors couldn't figure it out. And so he put, yeah, so he put all his information into ChatGPT, and ChatGPT ended up giving him the answer that worked. It suggested this thing, this medication. He asked his doctor about the medication. The doctor said, "Yeah, that seems like it would work." He started using the medication, and it works. And nothing has ever been working ever since. So, looks like Wick 589 is making pictures of boiling the oven to generate pictures of puppies. I'm not sure if I understand that, but I did think I read it wrong at first. I thought you were generating pictures of boiling puppies, so I'm really glad that you're not doing that. Let's go back in and check on the Bitcoin, see if I can share that with you guys without anything going failing the ocean. Wick's hallucinating over there. Okay. It's all right, Wick. You can hallucinate. It's allowed here. This is your safe space. Let's see. All right. Yep. Let's take a look real quick at the Bitcoin. So you can see just so dead right now. It was funny. I put in the 3 minute. But just look how flat this thing is. That's the thing. 3 minute. Look at just. So, yeah, like you guys know, I'm looking for it to sweep that a little high and then dump. Here's why. Look, let me show you. Here's why. You see all these head and shoulders we've been doing, right? Everything's a dang head and shoulder. So if you zoom out a little bit, right? So there's a head and shoulder right there. But if you look over here, we might as well complete this whole head and shoulder right there too. There's no reason why not. Just boom, boom, boom. Might as well complete it. That puts us 786, puts us at the value area low, puts us below the golden pocket. So I don't see why not. I think 84 and a half ish. Let me see, where is it? Yeah, that's below there. 84 and a half ish, 84.4. So that's what I'm looking at on that. Let me see. Looking for crypto. Yep, I do appreciate everybody that came in today. I know what you guys probably want to do. You probably want to enjoy a little bit of the club. I do invite you guys to take that link that's above my head right now, just to move it, but scan that QR code. That's how you get into the Patreon. You do get 90 days free of the $21 family tier membership. And so you get all of the content. So you get the brief, the deep dive sources, you get the explainer video, You get the critique and the debate all before our topic. So you can go through all of those before our live show on Saturdays. And then you guys can bring your questions to that. And then after the live show on Saturdays, I also drop into there the link to the actual notebook that I use to generate this podcast. And you can interact with it just like I did. You can add things to it, take things away from it, or just simply interact with it just like I did by clicking the little hand for the interactive. And then it'll pop up, you push play, and then as they're talking, you can join at any point in time and ask the questions yourself. So each Saturday, or after the live stream, somewhere between Saturday and Monday, it has been, I'm going to start to get it automated where it'll come out on Saturday. I think today's is automated. It should come out between 10 and 10:30. And then, so you guys can actually interact with that. Let's see, any other housekeeping that we have to do? I don't think so. I think we do have, obviously, we have the live show tomorrow at 4 p.m. my time, 5 p.m. your time, I think it is, on the Billy Goat Tales Network. That's our family live stream that we do each week where everybody comes together. Myself, Tex-Mex Bomex, Crypto Billy, Jimmy Jim, Redman, and oftentimes we will have Dark Crash or Darren Does Things that also joins us for the TA portion of that. That's a fun show each week. So we hope to see you there. And you guys know that we have the motivational mindset. Actually, it's called Motivational Crypto on Monday through Friday. And that comes out at 7:30 in the morning. Let's see, what else do we have? And of course, you know, Redman shorts, all the shorts come out. We probably put out now close to 100 shorts each week. So I don't expect each one of you guys to watch all of them, but it is really cool to see the recaps from the live shows and to see what Red puts out each week. And Tony is working on a lot of big things in the background. So I'm looking forward to seeing all that. But with all that being said, you guys know and you guys voted that you think I should, 60% of you guys, I think there were 15 votes, and that I should wear white. So we'll see about that. I'm probably just going to pick one color purple, but I think it would look a little bit better for, you know, the new year, where it's a little bit more than just propaganda. Shut up, get up, Jesse. I know that hip's working now. Let's go, K-Dig. Wick. Billy Goat Tales. Come on, Wick. Wick, come on, hallucinate a little bit with us. Crypto Billy, come on. Grab one of those twins or both of them and just dance. Just dance. Sing to them, Givers Game. Guys, energy, if you're not working, I hope you're dancing. If you are working, I hope you're dancing too. Let's go. See Nikki, do your dance. Let's go, T.I. I know you've been dancing. Your legs probably sore after those 4 miles yesterday. My goodness. Let's keep it moving. Let's go. Loco. Loco's dancing. I see you, Loco. Let's go. Thank you guys for starting Saturdays with me. This is fun. I like starting Saturdays by learning something new. Even if we learn something new that might be a little bit above our pay grade this time, we'll get it better. You know, this is a work in progress. We learn together. I love you guys. I really appreciate you guys. Can't wait to see you guys tomorrow. Really exciting. So I appreciate you guys. Share out the stream if you can. If you like it, share it out. You know, get other people in here. So see you next time. I'm gonna let this play through. It's gonna kind of mix over the top of our outro song. And so we'll have to just deal with that next while it's mixing. One more dance. Let's go. Let's go. All right. See y'all tomorrow.
In simple terms, we break it down. Complex stuff, we make it sound clear and easy for you and me. Billy Go Tales and Dave Digital bring knowledge we share. In simple terms, we're everywhere.
It's time to
We
open
love
the
you,
club.
fam.
It's time to
Hashtag
open the
Givers
club.
Game.